Next example. So this is a switch network where what is given is that the switch opens at t equal to 0. At t equal to 0, the switch is it's connected before. Now it is opening. And what we are asked to do is find output V0 of t. Well, where is V0? V0 is across the resistor. So this is what you're asked to find out. Okay, so help me with this problem. So what can I know at t equal to 0? How can I simplify the circuit? In the steady state, what happens with inductor? It's a short circuit. Yeah. Does everybody agree? Does everybody agree that at steady state, so before the switch is turned off, the inductor has spent a lot of time from minus infinity to 0, and it's a low frequency, so the impedance is 0, so it's basically a short. So does everybody agree that before the switch is moved, right, inductor is as if it's not there, it's a short, okay? Yes or no? Everybody with me on this? Okay. So now what we want to understand is what is the VO across R3, right? So now you see the power of superposition principle. Okay. So tell me, what is the current because of VS1? How do you calculate current because of VS1? Short VS2, okay, superposition principle. Now 2 ohms comes in parallel to 2 ohms, right? So what is 2 ohms parallel 2 ohms? 1 ohm, okay? Now 1 ohm in series with the 2 ohms is 3 ohms. So the current that is coming inside because of the 12 volt. So the 12 volt current because of 12 volt, I of 12 volt is going to be 12 volt by 3, about 4 amperes in the 2 ohms, right? Now 4 amperes. So are you clear how we got this? 4 amperes. I applied a superposition. I'll repeat it. I applied a superposition principle where the current in R3. Now I want to know that IR3 is a combination of or a linear sum of I because of 12 volt supply plus I because of 4 volt supply. I'm applying superposition principle. Okay. So now to calculate I because of 12 volts, I short all the remaining voltage sources, right? So I short the 4 volt source. It is a short. Now inductor is a short. Voltage source is a short. So 2 ohms R2 comes in parallel to R3. So 2 ohms comes in parallel to 2 ohms. You get 1 ohm. Now that 1 ohm is in series with 2 ohms. So R1. So you have total 3 ohms current across 12 volt. So you get a 4 ampere. So now 4 ampere is the current through the 2 ohms R1 resistor. 4 amps, right? Now this 4 amps should get split into half and half because the same impedance. So I of 12 volt is, is everybody clear? I of 12 ohms is going to be 2 ampere. Okay, so let's calculate. Help me with I of 4 volt, right? I want to do now 4 volts. What do I do? Let's take the eraser and short now the 12 volts because you can, so superposition principle, you can short the voltage source, right? Now R1 2 ohms comes in parallel to R3 2 ohms, it becomes 1 ohm. And this 1 ohm combination is in series with R2, so 3 ohms. So effectively, the current through IR3 in the R2 is going to be volts divided by 3 ohms. So minus 4 by 3. Is this clear? Yes or no? So minus 4 by 3 is this one. Okay. Minus 4 by 3 is the current that is going out of the 2 ohms. Should get split in both directions in half. So this will be minus 4 by 6, I guess. Correct? 4 volt. This is minus 4 volt. And I have 1 ohm in series, so 3 ohms. So it is minus 4 by 3 that comes out, but then gets split into 2. Yeah, it's minus 4 by 6. Or it is minus 2 by 3. So it is 2 by 3 ampere. So applying superposition principle, I can say that my initial current is going to be 4 by 3 amperes. So what is my voltage? The current is known. The voltage is 4 by 3 ampere into 2 volt. So it's going to be 8 by 3 volt. So all of this I'm doing before the switch is opened, right? All this calculation, whatever I'm doing is before the switch is opened. So I know that before the switch is opened, R3 sees 8 by 3 volt. Why? You have 4 by 3 amperes coming into that. So is this part clear? So my graph should always start with 8 by 3 volts. That is my initial voltage condition, right? So clear so far? Any queries, any questions?
Sir.
So now let's, go ahead. Sorry, somebody had a question? Can you apply which theorem?
You're asking for Milliman's theorem.
No, I mean, see, basically all of these are giving you the same answer, right? Just make sure that, why we don't want to have multiple theorems coming here, right? Because, it will simply confuse you. So let's just, I want to only focus on what is just necessary for you to understand. Of course, just be wary that, see whether this can be applied for linear elements and for independent sources. If yes, you can do it. There are multiple ways of doing it. I'm sure there are many theorems that you can do it. But let's just focus only on the on superposition principle. Okay? So, we got the initial condition. Now, what happens when? So, what did we get? 8 by initial voltage is 8 by 3 volts. So this is what we got. So let's write it down here. So it is 8 by 3 volts at. So this is V0 at 0 is by 3 volt. Okay, right? Is a VS2 and right? Take out this and redraw it. so that lesser elements, it's easy visually, makes it simpler. Life is simpler. Now at infinity, at t equal to infinity, what happens to the inductance? Again, same principle. At t equal to infinity, inductance becomes a yes. At t equal to infinity
becomes a short.
What happens to the inductor? It's a short, right? So now this is not there. Inductance is a short. So tell me, what is VO of infinity? What is the output voltage VOT at infinite time? Inductance is a short. You have 12 volts and there is 2 ohms and 2 ohms.
8/3 volts, sir. Same voltage. 8/3 volts, sir.
Why 8/3? Oh, your circuit is this. All of this is not there. Nothing is there here. This whole thing is gone, right? You have the 2 ohms, you have a short, and there's 2 ohms. That's it. This is all you have. What is the output voltage? What is the circuit? Yeah, 6 volts, right? It's 12 volts, and then you have 2 ohms and 2 ohms. That's it. Correct? And you are asked to find the voltage across 2 ohms. So it should be 6 volts. Correct? You agree? V infinity is 6 volts. Yes? Any confusion here?
No, sir.
Okay. So now you know it's a first order circuit. It starts at 8/3 volt and it is going to 6 volts. What it's at 8/3 volt. This is a waveform. Is to find out what is your time constant. Okay, so what is your time constant when the switch is disconnected? So you have L. So what is the time constant for an inductor? Base circuit, single first order inductor, L by R, right? That is your tau. Tau is L by R. So L is 2 Henry. What is your R? What is your R effective? So this R1 and R3, are they in series or are they in parallel?
They are in series. Series, sir.
Series. Why? Whatever is the current in R1 is the same current in R3, right? It is series. So R effective is basically 4 ohms and L is 2 Henry. So approximately, let's say 0.5 seconds, right? Is that correct? 2 Henry divided by 2 plus 2 ohms, so total R, yeah, 0.52. Yeah, that's it. So now you know the time constant, you know the tau. So obviously it should be e power minus t by something, t by 0.5 seconds, right? This is the only way possible for the time constant. It is starting from 8/3 and it should settle to 6 volts, right? So now if you, one way is to say, let's call this as, you can say that let solution be a plus b e power minus t by 0.5, right? Now you can say at t equal to infinity, you have output. How much is output? A, right? A should be 6 volts. So clearly this is 6 volts. Plus when t equal to 0, this is A plus B and A plus B is 8/3. So this should be, B should be minus of 6 minus 8/3 is how much? 18. So about 10/3. 10/3 e power minus t by 0.5. 10/3 is about 8/3 and at t equal to infinity is 6 volts. So that's another way to do it. It's because it is A plus B e power tau form, right? You know the initial condition, you know the final condition, you can solve for it. Okay. So is that clear? So what did we use here? Power of superposition principle to find the initial condition. Then we checked the initial voltage by assuming inductor to be a short, and the final voltage also assuming inductor to be short. We calculate the time constant and then we found out the thing. So I didn't do any differential equation here. No differential equations. Clear? I mean, of course, that doesn't mean you don't need to write it. You can of course solve it. Take V of x and then say that, or assume a current here, right? I of t, then do L di by dt is the voltage across this plus I3. So how do I write the equation? Let's write it down. Maybe it comes as a good practice. Okay. What I wanted to do was to write the differential equation. So that you get the practice of writing the differential equation, right? If you want to solve using that. So what do we want to assume? Let's assume this is I of t. Let's say I have I of t here and the same I of t goes to the inductor, right? So inductor, what is the voltage as a function of time? V is equal to L di by dt, correct? Voltage across the inductor VL. Let's say if this is the voltage across inductor, then VL is equal to L into di by dt. And what is this voltage? Voltage Vx, right? This is VL plus VO. Correct? This is the voltage across the inductor plus the voltage across the drop on the resistor 2 ohms. So Vx is equal to, Vx is the voltage across R1, on the right side of R1. So Vx is equal to LVL, which is the voltage drop across inductor plus the VO. Okay. So now VO is nothing but I of t into R3. I of t into R3, right? So now substitute all of this, we have di by dt, then there is I of t into R3, that is giving you the total voltage here. And you can now equate the currents, current through R1 and current through R2 is equal to I of t. That's another equation that you can write. So you can now get a complex, though first order differential equation and you can solve it. Club all the terms, club all the I of t terms, club all the di by dt terms, apply the, integral, effectively get the same thing, right? So you can also do it this way, the differential equation, but a more simplified and intuitive way is to just apply superposition principle, find out the initial condition, find out the final condition and do it. Why this is important is because in competitive examinations, so you are not expected to spend a lot of time on the question. So most times, right, people have a misconception that, the question is complex and it is wasting so much of time. The other way to look at it is the examiner or the examination team wants you to apply the correct way, correct transformation and solve it. Intuitively solve the question so that you answer it correctly. So it's not, the goal is not to waste your time. The goal is to help you. If you go the right way, you'll be able to solve it quickly. Okay? So let's erase this. So what is the final answer? Starts from 8/3 and is going to 6 volts, right? With a time constant of that, minus 0.5 seconds. Okay, so is this clear so far? Here, any questions on this? So let's move on.